Today we're going to learn about another way to charge an object, and that is by something called conduction or by contact. So we're going to look at charging by contact today. So let's go through. So let's fill in these notes for you. In addition to charging by friction, neutral objects can be charged by conduction. Charging an object by conduction requires contact between the object and an electrically charged sample. Once the objects touch, electrons can also be transferred through conduction. So, I'll give you a second to copy that down. So when an object is charged by conduction, it takes the same charge as the sample used to charge it. So an example, if a positively charged glass rod touches a pith ball, the pith ball will become the same charge, which is also positive. So that's sort of your rule for when you do charging by contact. Tomorrow we're going to look at charging by induction, and that's another way to charge an object, and your rules are going to be different for that, so keep an eye out for that. All right, so detecting electric charge. An electroscope is a device used to determine the type and the strength, relative strength, sorry, of an electric charge. So that was the thing in the flask that I showed you in class with the little metal leaves that can split apart. So there are two types of electroscopes, a pith ball electroscope, I've shown you that in class. So that was the one with the ball on the end of the string, and the metal leaf electroscope where the two leaves could separate. So when we draw, when we draw these, your diagrams, and you're going to have to do a lot of these drawings, you're going to be expected to do these drawings on your test. So when you draw a pith ball electroscope, the only part of the electroscope that we draw is the actual ball. And then we put our positive and negative charges in. Okay, so remember, if it's neutral, which is usually how it starts, it's got equal numbers of positive and negative charges. For a metal leaf electroscope, the diagram for that is a little bit different. Okay, we start with a ball on top, and then we have the stick that sort of goes straight down, and then we give it sort of, I call them little legs, sort of look like that, and these two legs are those metal leaves that I showed you in class split apart when there's a charge, okay? So in reality, this whole thing, that is what your diagram for a metal leaf electroscope looks like. In reality, we know this whole thing is sort of encased in a big flask. That's what I showed you in class, but you don't actually have to draw in the whole flask. We kind of just simplify the drawings so that we can go through them much more quickly. So now you know how to draw them. When we draw the metal leaf electroscope, if you want to put the charges on that, we can put some charges in the ball at the top, but we also just put some charges going down the metal rod and on both sides of the metal leaf. So you'll see charges like that as well. All right, so now detecting a charge using a metal leaf electroscope. So a metal leaf electroscope has two thin metal pieces called leaves that hang from a metal rod. The rod is attached at the top to a metal knob. When the charge is transferred to the knob, the charges can spread out over the whole structure. Why is it important that the knob and the rod are made of metal? So this is really important because without that, the electricity and the electrons couldn't move. So metal is a conductor, so the electrons can actually move through it, and you can detect a charge that way. So in a neutral electroscope, the leaves are closed, or they hang straight down. Okay. In a charged electroscope, the leaves are open, because what ends up happening is that they repel each other. So in this diagram here, what happened was all the electrons went towards the bottom of the electroscope. That made this area of the electroscope negatively charged. And we know already that like charges will repel, so because you've got negative charges on the leaves, they open up. All right, so what we're going to do is we're going to do a practice question. We're going to go through all your steps for this. So, using a series of diagrams, explain what will happen when an ebonite rod rubbed with wool touches a neutral pith ball. Hint, remember to always ask yourself what's happening to the electrons. okay? Because the electrons are the only ones that are allowed to move, remember. You're not allowed to move anything else. So, first off, oh, sorry, I'm just going to grab another slide here. Just going to insert a slide so that I can keep drawing. All right, so what you already have in your notes is a neutral pith ball, okay? So we have our neutral pith ball here. Oh dear, what happened to my notes? What's going on here? Nope. There we go. Let's try this again. Okay, so you have a neutral pith ball. So I'm going to write 4 positive and 4 negative charges on my pith ball. Okay, so you already have that in your notes. So in step 1 in your notes, it says explain what charge will build up on an ebonite rod when it's rubbed with wool. Okay, so this is separate from the pith ball. We're not touching the pith ball yet. We're just making a charged object, okay? So for step 1 on your notes, okay, you're going to rub an ebonite rod with some wool. Okay, so actually, you know what? Maybe I'll color code that for you guys. So my ebonite rod could be in blue, and my wool is going to be this stuff in green. So if you look at your electrostatic series, what should happen here? One's going to gain electrons, one's going to lose electrons. If you look at your electrostatic series, ebonite is towards the bottom and wool is towards the top. So that means that your ebonite is going to become negatively charged, and your wool is going to become positively charged. Okay, so what actually happens? You have some positive charges in your wool, and you have some negative charges in your wool. When they rub together, those negative charges move to the ebonite. Okay, so your final results over here, you have, here's my blue ebonite rod, okay, and I'll draw in, maybe it already had some positive and negative charges. There we go. So it has those positive and negative charges that it already had, but now it's got a few extra negative charges from the wool. Okay, so it is negatively charged. Okay, and then my wool is hanging out over here. And it still has some positive charges in it, because remember, the positive charges can't move. But it might only have a couple of negative charges left, so my wool ends up being positive. So that's what happens when we're rubbing the ebonite rod with the wool. So now we're going to take the ebonite rod, which is negative, and in step 2 it says, explain what will happen as the ebonite rod approaches the pith ball. Think about the electrons. So include a diagram and a written description. So I'm going to put that on the next slide. So in step 2, so we have our ebonite rod. It's got some positive charges, lots and lots and lots of negative charges. Okay, and it's going to come close to my neutral pith ball. So there's my pith ball. I didn't draw in the negative charges on purpose, because what's going to happen? As it gets close, the negative charges in my ebonite rod are going to force the negative charges on my pith ball to this side. Okay, because the negatives want to repel and get away. Okay, so that's basically what happens. So this is just as it approaches the pith ball, okay? So step 3, explain what will happen to the pith ball. So in step 3, what happens to the pith ball? Well, the pith ball gets a separation of charge. Now all the charges are over here. So this is called a separation of charge. Because again, that ebonite rod is really close. Now, once the pith ball touches the ebonite rod, so if I bring that ebonite rod even closer, So in step 4 in your notes, now I've got the pith ball here. I've got that separation of charge, but now my ebonite rod comes and actually touches the pith ball. So what do you think is going to happen to all those electrons on my ebonite rod? Well, in this case, they're going to be attracted to these positive charges. So all those negative charges are actually going to jump over and jump onto the pith ball. So I don't know, we'll say 3 of them jump over. So now in step 5, you take the ebonite rod away. So now the pith ball's here. Still has those 4 positive charges, still has those original 4 negative charges, but now it grabbed an extra couple of charges from the ebonite rod. So now overall, this has a negative charge. Okay, and remember, if we go back to our notes, I said that when you charge by contact, when you do these steps, you're basically going to end up with the same charge at the end. So I had a negative ebonite rod. When it touches your pith ball is going to end up with a negative charge. All right, you guys have another examples, but this example has to do with a metal leaf electroscope. So we're going to do that one together in class and clear up any questions that you guys have.